Hello! Today we will be going over Physics 2212, Lab 2, on magnetic field of a bar magnet. To start off, we have the purpose of this experiment, which is to measure the distance dependence of a magnetic field due to a small bar magnet. We will compose these measurements by using the distance dependence on Biot-Savart law. Some fundamental physics principles behind this experiment are the concept of magnetic fields, which are vectors that describe the magnetic influence on moving electric charges, electric currents, or magnetic materials. The Biot-Savart law allows us to calculate magnetic responses at an atomic or molecular level. Magnetic field superposition, which we actually saw the concept as electric field superposition in Lab 1, which helps us understand that all magnetic fields can be added and allow us to calculate the net magnetic field. And bar magnets, which in this case will be acting as magnetic dipoles. One important main result observation is that there is a correlation in the order of magnitude between the computational and analytical solution for the net magnetic field. We have now the relevant formula and materials used to make all our calculations in this experiment. On your left, you can see the list of the different versions of calculating a magnetic field for a bar, for a dipole on axis, the linearization of the x component in the magnetic field, and the last formula is the one to calculate the magnetic field off axis. The specific materials used for all calculations, we used the app Teslameter. We of course had our magnet bars. We used the Lab 2 Excel spreadsheet that will allow us to obtain specific values to calculate the magnetic dipole moment. We also have pieces of tape that we used in our cell phone and a ruler or meter stick to measure our distances. For the experiment setup, we first had to recognize the system and the surroundings for the experiment. The system was the magnetometer and the surroundings were the bar magnet and Earth. The initial condition was setting up the x component in a value closest to 0 as possible. The experiment was divided into two sections, first calculating the distances that we will insert in our spreadsheet for different x component values, and then calculating the same but for a 45 degrees value. And first, we had to calculate the magnetometer chip, which that was done by moving the cell phone perpendicular to our meter stick and obtaining the value where x was highest and y was minimum, and then rotating the cell phone to a 90 degrees Celsius and calculating where x was minimum and y was maximum. After this position was obtained, it was marked with an X, which you can see on your last picture, and that position was used to calculate all distances by moving the cell phone closer to the magnet or further from the magnet. As the distances were being obtained, these were being recorded in the Lab 2 Excel spreadsheet, which you have an image on this slide. And as you can see, the B net was automatically calculated for both cases. The one calculated it on axis, which we obtained the linearization formula, and the one of axis, which you can see at the bottom of the spreadsheet. To obtain our magnetic dipole moment, we first used the equations explained in the relevant formula slide, which were equated, and the magnetic dipole moment was isolated. To obtain the missing values on the formula, we used the information obtained from our graph, which we obtained our slope, which was of negative 2.955, and then we also obtained the value of k, which ended up being of 6.259 times 10 to the negative 7. All these values were inserted in the equation, and we obtained a magnetic dipole moment of 31.30. Now this value was going to be used in the computational model. After concluding the first part of the experiment, we could say that the magnetometer would give us a closer value to 0 in the x direction as we moved further away from the magnet, and as we moved closer to the magnet, this value in the x component increased. Moving into our computational model, here we have a screenshot of the major sections that were changed in our code. It is important to note that the function dipole B was developed, and this one will be called in the following sections to obtain the magnetic field on axis, off axis, and perpendicular. The next slide will also show the changes done in the rest of the code. Once the program was ran, we obtained the following diagram, where you can see the orange is the magnetic field on axis, the blue ones are perpendicular, and the purple one is that off axis. The major value obtained is the one at the last statement where we have the 2.719 e to the negative 5 for our magnetic field at a 45 degree. The major conclusion is that our computational result and our analytical result were not the same in value but the same in order of magnitude, which says that our calculations were not as far. And the main sources of error were human error and location by shifting the phone when taking measurements, or rounding errors, and location because there could have been other objects interfering with the magnetometer. To finish up in our discussion, we have the what if questions, and for the first question, this would have affected the results because Bx value would have been off, and that means that we would have had the Earth interfering with our magnetic field. And if the Mars magnet were connected into one, this would have been multiplied by the constant, and that would have been that we would just be using a stronger magnet. Thank you, and I hope this lab was helpful for everyone.